Okay, just a couple more examples for section 2.7. So, I'm actually taking problem number 14 from the book, and I have x minus 1 over 3 plus x plus 2 over 5 less than or equal to 3/5. Now, 3 and 5 go into 15, and because I have an inequality, like if I had an equality, I'm going to be able to multiply each. And what I actually am doing is I'm multiplying both sides by 15. And I'm using the distributive property, and so I'm distributing it to each term. A term, by definition, is bound together by division and multiplication. And you can say, well, there's a subtraction in there. There is a subtraction in there, but in the order of operations, division and multiplication is above, so it's stronger. It sort of usurps the authority of the addition and subtraction. So addition and subtraction separate terms, but if a term is bound by multiplication or division, that's all one object. So the 15 will distribute to this term, the 15 will distribute to this term, and the 15 distributes to this term. All right, so it's really going to read 15 over 1 times x minus 1 over 3 plus 15 over 1 times x plus 2 over 5, and then 3 over 5 times 15 over 1. And we can cancel. So 5 goes into 15 3 times, and 3 times 3 is the 9. The 5 will go into 15 3 times, but we distribute the 3. And this is where you get that effect of going to both parts, but you've got to do it in this order. So 3 times x is 3x, 3 times 2 is 6. 3 goes into 15 5 times, and you get 5x minus 5. Combining like terms, you get 8x plus 1 less than or equal to 9. Subtracting 1, you get 8x is less than or equal to 8. Divide by 8, you have x is less than or equal to 1. Now, your book is asking for you to do it in interval notation. And so what I did was, we're starting at negative 1, and we're going all the way over, negative infinity, and we're going all the way over to 1. We don't reach infinity, so we put a open bracket there, and we are obtaining 1 because we have the or equals, and so we put in the closed bracket. Okay? Now this one took me a second. I was trying something goofy here to see if I could come up with another way, but you have 3x plus 1 is greater than 2x plus 5 greater than x minus 7. You actually have two inequalities here. This is the first one, and here is the second one. And so I did the first one over here and the second one over here, and because they're put together and the arrows are going the same direction, and this is a little awkward how they wrote it, but the arrows are going the same direction. This is an and. We're looking for the overlap. So you have 3x plus 1 greater than 2x plus 5. And we subtract 1, so we have 3x is greater than 2x plus 4, subtract 2x, x is greater than 4. And we come over here and do this one. So we have the 2x plus 5 is greater than x minus 7. Subtracting 5, we get a negative 12. We're going to subtract x, and we get x is greater than negative 12. So if I draw this on the number line, I'm having x being greater than negative 12, which is off to this side, and x being greater than 4, which is off to this side. The and is from 4 off to infinity. So if we did it in interval or inequality notation, it would just be x is greater than 4. If we did it in interval notation, open bracket, because it's a hollow dot, and we are 4 off to infinity. Hopefully that makes sense, folks.